In this video, we're going to learn how to name alkanes. So we're going to use what's called the IUPAC method. And this is coming from the International Union of Pure and Applied Chemistry, IUPAC. So they're the ones who came up with all of these naming rules just to keep things consistent. Because if you have a bunch of different naming rules, then who knows what molecule you're referring to. So typically, using this method, we're going to name alkanes with a prefix, a root, and an ending. So the prefix is going to tell us the number and identity of any attached groups. So we might not need a prefix depending on the molecule. The root is going to tell us the longest carbon chain in the molecule. And then the ending is going to tell us about any functional groups that might be attached or present in the longest chain. So let's first start by going over simple alkanes. So let's start with the number of carbon atoms. So let's just number these 1, 2, 3, all the way down to 10. Now, each of these numbers will have a prefix to tell us how many carbon atoms we have. So if you have 1 carbon atom, the prefix will be meth. 2 carbon atoms, the prefix is F. 3 is prop. 4 is bute. 5 is pent. 6 is hex. 7 is hept, 8 is oct, 9 is non, and 10 is dec. Now, because we're just focusing on alkanes here, the ending for each of these will just be ANE. So if you have 1 carbon atom in your alkane, that's called methane. And the molecular formula, as we saw before, is CH4. And we're just using that same formula, CN, H, 2N plus 2. Now for methane, the structure will just be the same, CH4. All right, so now we're going to move down to row 2. So if you have 2 carbons in your chain, we're going to call that ethane. And let's see, how many hydrogens would we have on ethane? So if we have 2 carbons, then that would be 6 hydrogens. All right, and then the structure would be CH3, CH3. Okay, let's go to number 3. This molecule would be called propane. So that's what you use to cook with typically. And if we have 3 carbons, how many hydrogens would we have? 8. And we can plug that into the equation up above. And then the structure would be CH3, CH2, CH3. All right, so see if you can fill in the rest of this table on your own first. And when you unpause, we'll go over it together. All right, so you can probably start to see the pattern here. We're increasing the number of carbons by 1, and we're increasing the number of hydrogens by 2 each time. And all of the endings will be A and E, so we can just fill that in real quick. So we've got butane, pentane, hexane, heptane, etc. And I would like you to memorize all of these names for the simple alkanes because it's going to make the rest of your journey through organic chemistry so much easier. So definitely memorize those. I'll also post flashcards to help you remember those names. All right, let's fill in the molecular formulas. So we've got C4, C5, C6, etc. And now we just need to fill in the number of hydrogens. But as you can probably see from before, we're just increasing that by 2 each time. And you can just double check that this is valid by doing the math. All right, and finally C10H22. Okay, so for the structures, we're honestly just adding a CH2 group each time in the middle. And so I'll let you, fill these in if you want to, but you kind of get the idea, right? Okay, so let's move on to branched alkanes. So we did talk about normal versus branched alkanes in the previous lecture, but how do we name the branched alkanes? So let's say we start with N-butane. You can also just call this butane, but sometimes we'll put an N in front just to indicate that it's a normal alkane, not a branched alkane. Now, what if we then have a branched alkane with the same number of carbons and same number of hydrogens? Now notice we have a CH3 group bonded to that middle carbon. So we're going to call this isobutane. Okay, so now let's move down to the next row. We have N-pentane, so there's 5 carbons there. And if we look at the branched version, again, we have a CH3 group, but it's bonded to the second carbon in the chain. So this would be called isopentane. So notice that these are the same prefixes. Finally, let's look at N-hexane and compare that to the branched version, where again we have a CH3 group bonded to the second carbon in the chain. So can you guess what this will be called? Isohexane. So we're using that same prefix iso. Okay. So now keep those in mind as well as we go forward. Now sometimes we can have a group attached to our main chain of carbons, and we need a way to name that group that's coming off of the main chain. So if you do have a carbon group coming off of the main chain, that would be called an alkyl group. So it's kind of like alkane, but we're just changing that ANE ending to alkyl, YL, alkyl group. So an alkyl group differs by 1 hydrogen from an alkane. So let's look down below. Let's look at methane, which we know is CH4. Now, if we take 1 hydrogen away, it becomes CH3, and we can imagine that it's bonded to some carbon chain. Now, if that's the case, we're going to call this alkyl group a methyl. So we went from ANE to YL to indicate that we have an alkyl group instead of the parent alkane. And then we can do the same for ethane. If we take away a hydrogen and assume this is bonded to a carbon chain, it becomes ethyl. Propane becomes propyl, but because we have a couple of different places that we could connect to this propyl group, we actually do have another name. So if the connection point is on the middle carbon there, this becomes isopropyl. So there's that iso prefix again. However, if the connection is just on the end, then it's just propyl. And again, I'll put some flashcards up for you just so you can kind of remember all of these names. Now, it does get even more complex as we add more carbons onto these alkyl groups. So for instance, if we have 4 carbons on the alkyl group, if it's connected at the very end, it's just butyl. But if it's connected on one of these middle carbons, it's called sec-butyl. So that gets a little confusing, right? Now, what gets even more confusing is if we have isobutane as kind of our starting point, and then we remove a hydrogen from the end, this is isobutyl, so that's easy enough. But what if we connect in the middle to our chain? Then that becomes T-butyl or tert-butyl. Now, this has to do with what are called secondary and tertiary carbons. Don't worry about it too much. For now, just try to memorize the names. And again, I'll post some flashcards for you to make it a bit easier. All right, now what if you have a non-alkyl group that's bonded to your carbon chain? So this could be a fluorine, a chlorine, a bromine, an iodine, maybe an NO2 group, NH2. So these also have names. And for instance, fluorine, if it's a non-alkyl group on your chain, we're going to call that fluoro. Same for chlorine, that becomes chloro. Bromine becomes bromo. Iodine becomes iodo. NO2 is nitro. NH2 is amino. So these will be really handy as we move forward in organic chemistry. All right, so let's go through the process of naming more complex molecules or alkanes. For instance, branched alkanes. So in the first step, we're going to identify and name the longest carbon chain. So this is going to give us the root and the ending. But remember, in this case, we're just naming alkanes, so the ending will always be ANE. Then we're going to number the longest carbon chain to give the lowest number to any carbon to which a group is attached. So looking down below, we have an example. Let's see, we have our longest chain is 1, 2, 3, 4, 5. And there's a couple different ways that we could number this, right? We could start on the left or on the right and then move across. But again, we want to make sure that we're giving the lowest number to any branches. So we do have a branch here. And do you remember what that would be called? That CH3 group? Methyl. Now, I did kind of give it to you down below there, but this methyl group has to have the lowest number possible. So we could have numbered this from left to right, but then the methyl group would be on carbon 4, and that's not what we want. We want to make sure it has the lowest number possible. Oh, whoops. So we're going to number from right to left, and it will be on carbon number 2. Okay, so we already kind of took care of step 3. We located and named the attached alkyl group. We said it's a methyl group on carbon 2. And now we're just going to combine everything into the name. So we've got 2-methyl pentane. So we're indicating the group that's attached, the methyl group, and it's on carbon 2, so we have 2-methyl. And our longest carbon chain was a chain of 5, so that would be pentane. Okay, now what if we have multiple branches? So for multiple branches, we want to show the location of each branch with numbers. And we do want to try to give those branches the lowest numbers possible, again. Now, if you do have multiple branches of the same type, we'll change the name by adding a prefix. So di would indicate that we have 2 of the same branch. Tri is 3 of the same. Tetra is 4 of the same. Penta is 5 of the same group, etc. Typically, you'll only see di and tri, for example. And then we're going to separate the position numbers by commas. Next, we're going to list the multiple branches alphabetically, but we're going to ignore any prefixes like di, tri, sec, and t. So looking down below, let's identify the longest branch, longest parent chain of carbons. So that would be 1, 2, 3, 4, 5, 6, 7. Because, for example, let's say that we're going along and we went down this way. That would only be 6 carbons. So that's not the longest chain. So you always want to make sure you have the longest chain. Okay, and notice that this was numbered from left to right because we want to make sure that any branches have the lowest numbers possible. Okay, so it looks like our branches are methyl, methyl, and then the third branch there, we have a connection point on the middle carbon, and we have 3 carbons total. So 3 carbons tells us we have propane, but this is an alkyl group, so this becomes propyl. And then because it's connected to the middle carbon, we're going to add iso in front. So this will be our isopropyl group that's attached. All right, so now let's put everything together. Now, again, we're going to alphabetize. So what would come first, the methyl groups or the isopropyl group? Isopropyl. And when you're using that iso prefix, we actually do include it in alphabetizing. And I know that's really confusing, but it's okay. You'll get used to it as we do more and more practice problems. Okay, so isopropyl is going to go first, and it's on carbon 4. So we've got 4-isopropyl. And then let's use a different color for these methyl groups. We have 2 methyl groups, so we're going to call that dimethyl. And one of those methyl groups is on carbon 2. The other is on carbon 3. So this will be 2,3-dimethyl. And notice that we're putting dashes or hyphens in between. All right, and then last, we're just going to put the longest carbon chain. And we had 7 carbons, so that would be heptane. So the full name is 4-isopropyl 2,3-dimethyl heptane. Whew, that's a lot. Okay. So let's do a couple more practice problems. So here I've drawn a couple of different structures. They're a little bit easier than the last one we did. See if you can figure out the names for these 2 molecules. And you can pause the video, and when you unpause, we'll go over it together. Okay, let's name the first molecule. So let's try to find the longest carbon chain. Let's see. So it looks like we have 5 carbons in our longest carbon chain. And then we have this branch that's coming off. Okay, so first, what would we call that branch? What's the name of that alkyl group? Methyl. All right, and let's number our carbons so that the methyl group is on the lowest or has the lowest number possible. Now in this case our molecule is symmetrical, so it doesn't really matter which way we number it. We're going to end up with the methyl group on carbon 3. Okay, so that's 3-methyl. And now we have to name our longest carbon chain. So if we have 5 carbons in that longest chain, what is the name of that? Pentane. And it's okay if you're still learning all of these prefixes. We just learned them, so don't worry. It'll become second nature as we keep going. Okay, let's do the second one. So let's find the longest carbon chain. Let's see, so we've got 1, 2, 3, 4. All right, and it looks like we have 2 branches coming off of that chain. And what are the names of those alkyl groups? Methyl. So they're both methyl. All right, and let's number the longest carbon chain so that those 2 methyl groups have the lowest number possible. So it looks like we'll probably want to number from left to right. So 1, 2, 3, 4. So both methyl groups are on carbon 2. So we're going to write 2, 2 dash dimethyl. Now, this might seem redundant, but you do have to list the numbers for both methyl groups, even if they're on the same carbon. So we would write 2, 2, and then don't forget the di prefix to indicate that we have 2 methyl groups. All right, so now we just have to name the longest carbon chain. So if you have 4 carbons in your longest chain, how would we name that? Butane. All right, so the full name is 2,2-dimethyl butane. Great. Okay, and then there's also going to be a naming worksheet, so you can work through that as well and just get some practice with all of these different names. Because I do know this is a lot at first, and it can be kind of confusing to keep track of. Okay, so we'll stop the video there. In the next one, we're going to talk about a group, of alkanes called cycloalkanes. So these all have ring structures. So I will see you then.